Hey guys, welcome back to my Solidity writing, testing, and deployment guide video. So we're gonna start building the wallet now. Oh, by the way, I added a caret here, so it means I'm using any compiler from 0.8 upward. Alright, first of all, I need to get rid of this. So in this video, we're going to be working with data types, almost all the data types. Then need to be a T here. Good. Then work with struct and event. No, we work with constructor first. Constructor and event. Then some functions. I think this should be enough. Alright. This is enough for one video. Okay. To get started, most of our variables are going to be state variables, by the way. First of all, I need a wallet owner, so I'll declare it right now. Address wallet owner. You should do fine, but we want this wallet owner to be payable, so you have to make sure it's payable so you can receive data. Then I think that's my first state variable. Then for the struct, I'm going to create a struct for transaction. Struct here is struct here in Solidity looks like object in JavaScript. Yeah, that's how I can describe it. Transaction takes ID uint. Anytime you see me using uint, simply referring to the uint 256 by default. So an ID for the transaction, I need a string for the subject or the tag for the transaction. Then that subject can be a note or whatsoever you want to add to it. I need another uint for the amount or value of data transfer. And I need another address or the first address to declare if it's a sender or a receiver. Ideally, I just discovered this font size is small, so I can increase it and close this part. Now we have enough space, and I can even close this console too. Good. This is what the structs look like in Solidity. Alright. Then I need another state variable. Yeah, state variable. Why am I making so much typos? And this time it's going to be a public one. Uint public, and I'm going to call this history count, so that I can keep track of my transactions. Then let's work with arrays. So many data types we're going to work with today. Alright, I'll call this transaction in array. So I'm casting the transaction struct to this array, and gonna make it public. History, because I don't want to call it transaction again, so I'll just leave it at history. Time to work with our constructor. Down here, I'm going to say put my constructor keyword, constructor, then no parameter, for this constructor. What I want to do here is I want to make the whosoever deploys this contract to the blockchain the wallet owner. So to do that, I'm going to call that wallet owner at the top, and I'm going to say wallet owner equals message for sender. This makes sense, but we have to make it payable. So to do that, move backward a bit and write payable, else to return an error when we try to transfer to the wallet owner. To return an error saying the wallet owner is not payable, so he can't receive it. Then another thing I need to do is, since the constructor is the section of the code that gets executed only once, I'm taking advantage of that to initialize values for these two variables. Alright, that makes sense. Wallet owner is whosoever deploys this contract to the blockchain, and history count should be at 0. Alright, let's work with events, then work with modifiers, then work with functions. Alright, so I need to make an event for, you know what, let's just make the function first. So down here, I'm going to make a function, and I'm going to name this function deposit. Alright, function deposit, SIT. It's a public function and it's payable. Alright, and I want to push into the history array the record of this transaction. Okay, so what I'm going to do here is I'm going to push into it history.push. So I'm setting this transaction as a value of an array, of the history array transaction. And I'm going to use the history count plus plus. You know what the plus plus means? Increment by 1. Okay, alright, history count plus plus as the first argument. Then the second value for this subject right here is a string. So I'm going to say deposit. Then the third one is, I think the third one is amount. Yeah, it's amount. You can see it right here. Amount. Alright. The amount is message.value. And it's the value of whatever is sent to this, is sent whenever this function is called. Then I think the fourth one is the sender. Yeah, the sender before the receiver. So the sender is going to be message.sender, and the receiver, nobody is receiving. accept the contract of the address of this contract. So I'm going to use the, by the way, it's not a string, it's an address type. I'm going to use address this. Hey, remember this? We just use this object when we were working on the first video. All right, and now we can set our event. So my event, I'm going to call this event, and I'm going to use the, how am I going to name this event? Okay, I'll name it deposited. Then I'll pass in value and parameters of what the event should expect, okay, when it will get, when we will emit it. So I'm going to say the first value is a new int, and I want it indexed, and what is coming first is the amount. Then I'll say string. The string is the message. The message is the same thing as the subject, but I don't want to use the subject again because I already used the subject as a variable name. Then I want the address of the depositor. Let me just take advantage of this and set the event for the transfer or spending. Then I'm going to say uint index amount. Then I want a string of message. Then I want an address of the receiver of who we transfer to. You can either use receiver or to. Alright. Then down here I'm going to check if this deposit is successful, then I'm going to emit the event, emit deposited, and then I'll pass in the value for each of these parameters here. So I'll pass in the argument for them. Let's do this. Deposit, emit deposited. Now I'm going to pass in the values. So for this amount, I'm going to pass in the message.value of this deposit function. Alright, so the amount goes like message.value, then the message deposit, I'll do deposited by then the depositor, I'll put message dot sender, then a semicolon here. So once this transaction is successful, this event will be emitted. Okay, alright, let's make the function for transfer or withdrawal or cash out. We need to pass in some parameters like the address of who we are sending to and the amount. Alright, we need an address to all receiver, comma, then we need you know what, I'm going to change this name to individual. Yeah, individual. But I'm not sure it's an individual I'm transferring to. It could be another contract I'm transferring to. But anyhow, individual sounds cool. Makes it personalized. Then I want a uint of the amount I'm transferring to the individual. Then this function is going to be public. So anybody can call it, right? Wrong. We'll make a modifier right now. Alright. So first thing first, I'll make sure I'll ensure that my balance times the contract balance is greater than what I'm requesting to transfer. So ensure that wallet balance is greater than, oh, that's a greater than sign, greater than request. I'm going to do this. Require, this is my first require statement in this contract. Require address this dot balance is greater than or equals to amount, that means this variable, this amount here. If that's not true, return insufficient balance. Then I'll put my semicolon. Then, but if we have enough, then execute this. So to be executed if the balance is more than enough. Alright, trying to keep comments in my code. Then if the balance is more than enough, I'm going to say make the transfer straight up to this individual. I'll use the transfer keyword. So I'll say individual dot transfer whatsoever amount I pass in when I call this function. Then I'm going to emit my event. This transfer event. Right now I'm going to pass in the values for that. So let's do that. I'll say emit transfer. Oh, just notice something. This is just transfer. Add ed to it. Alright. Transfer. Then I'll pass in the value. It's taking an amount. In here I'll pass in amount. Then as the message, I'm going to pass in you just transferred if RED transferred to, then I'll put the receiver here, individual. Alright, then my semicolon. Just looking good. Then one more thing, we can leave this like this. So if we leave this function transfer like this, anybody can call it. You know what that means? If there's no restriction, somebody can keep calling this transfer function until our ether, until the contract runs out of ether, and that is bad. So let's create a modifier. So up here, before the array or after my constructor, yeah, like putting my modifiers after my constructor. My constructor modifier, then I'm going to use my modifier keyword right now. I'll say modifier, modifier, not not fire like that, like FIER, not FIRE, FIER, yeah, modifier. Then I'm going to give it a name. So what should I give this? I'll say only owner. Almost everybody uses this in their tutorial. You know what? I'll name it owner privilege. OWNER, owner privilege. Privilege, LEGE. I know how to spell privilege, I promise. And then no parameter. I'm just gonna require that the message to sender. Message to sender is the wallet owner. If it's not the wallet owner, I'll say only the owner of this wallet can call this function. Then a semicolon. I don't like errors. Alright, one more thing. Down here we need to pass in a semicolon. No, underscore, then a semicolon. That is how it works. So this underscore is representing the function that comes next. So right here in our transfer, we're going to make it secured by adding a password called only owner. Oh, owner privilege, sorry. Alright, now this function is safe. One more thing, I need a function to display my wallet balance. So let's create that one. Function, oh, I need to add a comment. Show or display my balance. Then go and name this function balance. It's going to be public and it's going to be a view since it's not modifying the state of the blockchain, and it's going to returns uint. Then I'll say return address this dot balance. Bro, this tutorial is getting too long, don't you think? I think we should end it right now. Okay, I'm not going to end it right now. One more thing, I want to make sure we have a destructor. So, oh, before we do that, I want us to be able to get the history. remember that get history. The history is an array, right? So I want us to be able to get the history and to be able to track a specific transaction. Yeah, so let's do that. First of all, let's work on the get history function to display history of the wallet. So it's going to return all the transactions the wallet has ever had. Alright, function history. I need to, no, not history count. I need to put a G here. Get, then make this camel case. Yeah. History. This is going to be a public and a view too. Public view, and it returns my transaction. Remember the transaction struct that casted to an array. That's what I'm going to return. And we have to make it memory, or else it will compile successfully to return one kind of error. Then I want it to return the history. That means the history array will return history. Semicolon. This history is this array at the top. Let me show you. Why did I keep it here? This one. This is it here. History, this public one. Then I need another function to get a single transaction. So what I'm going to do is, let me make this align. And get single transaction. I'll use a function to function get transaction. Then I'll pass in a parameter of uint id. It's the ID of the particular transaction. Then public view, and it returns a transaction, and it returns a struct. This time we're not returning array, we're returning a struct. Return transaction. Then make this memory too, so we can be safe. Then I'll return the, return my history. This is an array, but I'm passing, array indexes begins at 0. Then if I want to get the first transaction, I'm going to have to use 0. And since this transaction ID here, this history count, the first transaction is going to get incremented to 1. See, it's going to get incremented to 1, and we passed it in as a value of an array. So we need to make sure the index, the ID of the transaction we're fetching is the same with the index of the array. So check what I'm going to do. I'm going to say this ID minus id minus 1. I hope you understand what this does. So if the id of the transaction is 1, it's going to be 1 minus 1, which is 0, meaning the first value of the array times the, if the value here is 0, we're going to be calling the history with the index of 0, and if the value here is 2, we're going to be calling the history with the index of 1. Hopefully that makes sense. Then the last thing I want us to do is utilize the suicide or self-destruct. That's not even the last thing. I need a callback function so that if anybody transfers ether to us mistakenly, we'll be able to catch it. So their money no go loss. Alright, let's do this. Function or callback function or fallback. This is the defender. So I'm going to say function receive. I think receive is a special keyword. Did I not spell it well? RECEIVE is how to spell receive. Then it's a fallback function. We don't need to pass in anything, it will just do its job. Then I need 1 for the self-destruct. So destroy contract. On my command, so I'm going to call this function destroy. Then this is going to be public and owner privilege. Then in here I'm going to call the self-destruct function. Then I'll send the balance to the wallet owner. Alright, I think that's all for this contract. Oh, long enough. 90 lines. Let me just go through it one more time and see if there's anything I can edit. Alright, I just realized I didn't put payable here, so this needs to be payable. PUBLIC, public and payable. Good. Thank God I cross-checked it. And let's go up a bit. This is correct. Don't worry, you'll understand this when we compare the contract if you have any issue with that. Yeah, I like this one. It's working fine. It's just a piece of notification so that you grab the context. Then here too, inside the comment and call it notification. Alright, we have a modifier, we have events. I think that's, we're good to go. Compile. Hopefully there won't be there's an error. Let's see what the error is about. Warning. This function name okay, that's not even the main error. So member push is not found. Okay, history count. Oh, there's a typo around here. This is supposed to be history, not history count. I think the autocomplete did that for me. Then I think there's another one. Individual does. Okay. Said individual is not payable. So I need to make it payable. So what line? 57. Alright. Okay. Address payable. Address. Oh, the payable doesn't go there. Okay. Well, good to go. This yellow warning is something we can ignore. Just saying we should remove the payable keyword here. Because by default it's payable. This function is named receive, but is not the receive function of the contract. Okay, so I should remove the function keyword. Alright. Oh, not public, external. Then okay, so I should add my payable back again. Just want to make sure there's no error. Okay, we're good to go. We made it external and payable. Thanks for watching me debug. Alright, time to deploy. We can deploy this contract now if you just hit this deploy button. And time to watch the magic. Alright, first of all, I want to delete these ones. And we deploy again. Okay, now check this out. Here we go. Our wallet is all set. So we can deposit, we can destroy, we can transfer, we can check balance, get history, get transaction, and get a single history too. Oh, okay. I didn't expect this to show, but anyhow, it's still good. And history count should be at 0 by default. Alright, it's at 0, you can see it right here. Then let's see if I can increase this font size. Yeah, I can. Just want to make this side bolder for y'all to see. Alright, let's start with the first function. Our first function here was deposit. Okay, let's scroll up and in this value input, put in the amount you want to transfer. I want to transfer 70 way, not 70 way, 70 ether. Then scroll down, click deposit. Wait for it to still sign in. Alright, if you look up here, you see 78. That's my balance now. And to prove that the balance function is working, check this out. See, showing 70 times 10 raised to the power of 18. That is 70 ether. Then, okay, the next function here is transfer. Let's make a transfer from our wallet to this address. Just need to copy this address and switch back to the owner. So This function takes in the individual, which is an address. So I'll paste in address and the amount I want to send to it. So to make sure that our required this.balance is greater than amount is working, I'm going to put 80 here because we do not have 80 ethers in our balance. So expect an error. Oh shit, I transferred 80 way instead of 80 ethers. Okay, let's do that again. So we have 80. We have to count 18 zeros now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then transfer. Expect an error. It should fail. Listing on all transaction. Okay, spending. We failed. Transaction failed. Let's check it out. Okay, click this and you see the message. Okay, I'm expecting a message. Okay, insufficient balance. I can see it right here. Insufficient balance. So our function was working. And another thing I want to make sure is working is I want to check if our modifier is working. So I'm going to call the transfer from an address that's not the owner. Alright, check this out. Transfer. This time I'm expecting our modifier to work. Let me drag the console up a bit. Alright, and I can see the message, only owner can call this function. Okay, it's working. Let's switch back to our owner. Then, okay, we can check our balance now. It should have reduced because we transferred 8 way. Okay, now we have 69,999,999,999,999,999,20. Then check this out. Get history. Get history is working. Yeah, it works. History has a deposit of 70 ethers and it returned only 1. I wonder why. I was expecting more. Let's see if we can get something around it because we made a transfer. Zero. I was expecting like 2 because we made a transfer. We didn't make only deposit. You know what? Let's make another transfer. For this time, I'll change this to 30. Now transfer to the same guy. Transfer is pending. Okay, successful. Then get history now. Get history is still showing 1. Oh, still showing 1. And I'm not sure. It's not supposed to be showing 1. It's supposed to be showing the whole array. Oh shit. I know why. Because we didn't push the transfer, did we? No, we didn't. We didn't push the transfer. Okay, let's do that now. Then we'll have to redeploy this contract. Sorry guys, let's do that now. History dot push. Let's see what our history takes, by the way. Okay, it takes a transaction struct, then we pass in the value. You know what? You can just copy this one and modify it. Control C and put it in here. See, that's why I call this course the writing, testing, and deployment guide. Because when you deploy your smart contract to the blockchain, you can't modify it again. It's gone. Okay, now we're going to increase the ID, and the subject is going to be transfer. Then here won't be amount, here will be amount. Sorry, that won't be message, just saying that replace it as amount, because we're passing an amount as a parameter here of this function. And there's nothing like message or sender here, so change this to individual. Then oh, the individual is the receiver, right? Let me check this structure one more time. The receiver comes first before the sender. Okay, there's a sender before the receiver. Alright. So the person sending is the address of this. That means the contract is the one sending, and the receiver is the individual. Alright. Need to put this semicolon here, then save. Okay, compiled successfully. Let's deploy it. First of all, I have to delete this one. Then I have to make new transactions. Deploy. Okay, deploy went successful. Now I need to deposit. Deposit 20 ethers. Deposit. Need to clear this console. Then need to drag this console up. Okay, deposit was successful. Then check balance. She have 20 ethers. Now we can transfer to that same guy. Oh, I need an address to transfer to. Copy this address. Then switch back to my main account, the owner. So I want to transfer to this guy, and I want to transfer 2 ethers. So 2 times 10 raised to the power of 18. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then click transfer. Spending. Alright, was successful. Then can click get history now. Alright, it's working fine now. Get history is showing more than 1 now. Alright, it's working fine. Get history and checking the details, I can see a tuple. Down here, I can see one message. Subject is deposit, and I can see a subject of transfer right here. And if you check here, you see it around here, transfer for the array with the for the struct with the ID of 1, there's a transfer, and for the struct with the ID of 0, there's a deposit. So it's working fine. And now we can get the transaction by using the ID of 1 to return the first transaction. Alright, it says deposit is the first transaction of 2 ethers, of 20 ethers. Sorry. And get the second one, return the array with the index of 1. You can see it's working. Then if you want to get the specific history, this time we're working with array, a clean array. You need to put the index of 0 to get the first one. You can see now it's working fine. We have the ID is 0, the subject is deposit, and the amount is sender and the receiver. Then if you want to get the second value of an array, you need to use the index of 1, then click history. So the difference between this history and the get transaction is that the get transaction converts a number into an array index, while the history uses the direct array index. That makes sense. As I was trying to explain in the contract, and you can check your history count. Should be 2. Good. It is 2 because we had 2 transactions. Alright guys, that's it for this video, and I hope you enjoyed it. Have fun. Remember to stay productive and stay motivated.